let's look at some problems involving solving trig equations, finding the solutions, where we have a multiple of x as the input for the trig equation. So find all real numbers that satisfy the equation 2 cosine 3x plus 1. So the first thing to do is to get cosine of 3x on a side by itself, to isolate it. We're going to subtract 1 to the other side. Then I'm going to divide both sides by 2. Now, what you'd really like to do is you'd like to get x by itself. Now, recognize that cosine of 3x being negative 1/2 means that you can think about that as being the adjacent over the hypotenuse, or you can think about on the unit circle the x value of cosine. Cosine gives you the x value. The x value of your angle being negative 1/2. So that means somehow my angle looks like that or like that. So essentially, if you type in cosine inverse of 1/2, cosine inverse is going to assume that you're in the first or the second quadrant, and you are going to get, let's say we're in radians, you're going to get the angle 2 pi thirds. That's that angle, okay? So cosine inverse of 1/2 is 2 pi thirds. Now recognize you could also be down here, that's symmetric, so negative 2 pi thirds would also give you a cosine value of negative 1/2. I should write a negative there. Okay, so we've got these two values. Of course, cosine is even, so positives or negatives give you the same output for cosine. Of course, what this says is it says that 3x is supposed to be equal to either of those, but 3x is either equal to 2 pi thirds or it's equal to multiples of 2 pi thirds. So for instance, if you went all the way around and then came back here, that would be 2 pi thirds plus 2 pi. The 2 pi would get you a full revolution. 2 pi thirds would get you around to there. You could have any multiple of this you want, so we write 2 pi times k, where k is any integer. Or you could have 3x equals negative 2 pi thirds plus 2 pi k. And so you should be able to check this at any step. If you put 2 pi thirds in for the 3x up here, the equation should still be true. And if you put negative 2 pi thirds or negative 2 pi thirds plus 2 pi in for 3x, this equation should still be true. Well, we'd like to tell exactly what value of x comes out as a solution to this. So we still need to isolate x. That means that if we divide everything by 3, we're going to get to that. So typically we write the solution set as the set of x such that x equals, now notice I'm dividing this equation by 3, x equals 2 pi ninths plus 2 pi thirds, dividing this by 3, dividing that by 3, or x could equal negative 2 pi ninths plus 2 pi thirds over k. You really ought to convince yourself that this is true. Take the value 2 pi ninths, plug it in here, make sure that this whole left side equals 0. Or take 2 pi ninths plus 2 pi thirds, put it in for that value, or any of these. But this is the set of solutions.